Welcome to Engineering Mechanics. Here is a question on force system. The question says three couples are formed by the three pairs of equal and opposite forces. Determine the resultant term of the three couple. As you can see, this is a couple because don't forget from the definition of our couple, they have the same magnitude but different direction, So that means this and this is a couple. Also, this and this is a couple. Same likewise, this and this is a couple. So now we know taking our moment is equals to our r, position distance cross the force. So now let's start from this. Now this is how we go about couple. Don't forget, let's say this is where the first couple is being happened, and this is where the second couple is being happened. So if we pick that we are starting from this particular, but don't forget that if we look for the resultant of this particular two couple is 0, because this one is they are both going in different direction. So that means we subtract, that's 100 minus 100, because this one is heading towards the positive, towards the negative. 100 minus 100, so that's 0. So that means if we pick that we are starting on this particular force here, so that means we will be ending at this particular force here. So don't forget this is a 3D dimension, 3D. So let's say this is where the first 100 Newton is. This will be like the position distance. Let's first of all write the position distance. Let me call this 100 m1, the moment about m1. So we'll be having r, the position, to be equals to, now this is the x-axis. This is where the x-axis is. This is our y-axis, and this is our z-axis. So that means, as you can see, we are heading in this direction. That means we are going towards the positive x-axis. Convert everything to meter. That's 0 in I direction plus 0.2 in j direction plus 0 in k direction. Why also our force? Since we said our starting point is from this particular 100 Newton that is going in that one direction, that means we are neglecting this particular 100 Newton that was here. So that means we are using this particular one in this direction, the second one. So that means, don't forget, at this particular point it is parallel to both our x and y axis, because don't forget it's going in the negative direction of z. So that means we are having 0 in 9 plus 0 in g, 100 in k direction. So that means we go about this. So that means we're having I, j, k, 0 is 0.2, 0 is 0, 0 minus 100. So that means in this case, if we pick I, we'll be having I into bracket 0 minus 20 plus 0. So that means we are having minus 20, because don't forget your j will be 0 times 100 times 0 is 0 times 0. Your k will also be 0. So that means we are having minus 20 in I direction, Newton meter. This for the first one. So let's say this particular point here should be our starting point. So we have to resolve if this particular point is our starting point. So that means we go in this direction. So you get, let's first of all, for m2 we still know r to be cross f. So that means for our r, for this second one, don't forget we know the position distance from here to be 0.1 plus 0.2, which is 0.3 in j direction, which is equals to 0 in I direction, just going towards the positive, 0.3 in j direction plus 0 in k direction. Then our f, which is our force. So that means we have to resolve this particular force that is here. So that means don't forget since we are starting here, that means we are less concerned about this particular force that was here. So that means we do our resolution here in this sense. So that means we do it in this sense, and we go in this sense. So for this particular y-axis, don't forget this is our y-axis. Let me bring out the diagram here. Let me bring out the diagram here. So that means we'll be having something of this manner. So that means the angle here is 45 degrees. According to this diagram here, so that means here is our y-axis. Then that means here is our x-axis. So that means if you resolve this for your y-axis, you'll be having f. Your f is going towards the negative, so that means you'll be having minus f sin theta here. And then for your x is going towards the positive, which is f cos theta. 45 degrees in y direction minus 120 sin 45 degrees in j direction plus 0 in k direction. So that means our f will be equals to, let's erase this out of the chart, our f will be equals to 84.85 in y direction minus 84.85 in j direction. So that means our moment for this second one will be I, J and K. Then we are having 0, 0.3 and 0. For this we are having 84.85. Then for this we are having minus 84.85. Then for this we are having 0. So that means going about the resolution of this, our I here is 0, because we will be having I into bracket this times this times this, which is 0, minus j into bracket. So that means picking our j, will be having 0 minus 84.83 times 0, 0 minus 0 rather. That means for this our g, because picking g, we won't be picking anything, 0 times 0, 84.5 times 0, then plus k into brackets. So that means we are not picking anything here, 0 minus 84.85 times 0.3, 84.55. So that means our moment about this second point is equals to 25.455 Newton meter. Don't forget it will be negative. So that's for the second part. Now for the third part, we know our moment about 3 is equals to r cross f also. So now let's resolve this. So that means in this case, don't forget we have this in this sense, but we don't know which axis this particular one is going. We also have this in this sense, we also have this in this sense. So now for the first resolution, let's first of all get the position distance. Don't forget, let me erase all this stuff that was being put. So don't forget, this will be towards the x-axis, and this will be towards the y-axis, and this will be towards the z-axis. Don't forget, I'm picking this as my this will be towards the z-axis. Don't forget, I'm picking this as my starting point, so that means I will be going in this direction, also in this direction. So that means my r will be equals to, for this direction of z, it will be equals to 0.18, because this is the position distance, 0.18 sine 30 degrees. So that means I'm having 0 in y direction, because I'm not going towards the x, then plus this will be 0.18 cos 30 degree in j direction, then plus this will be 0.18 sine 30 degree in k direction. That's for my position. So that means let me write this out. That means that my r will be equals to, that means I will be having 0.156 in j direction, 0.09 in k direction. Now let's go about the resolution of this first. If we say this, don't forget we'll be having this. Let me use a bold line. We'll be having this, we'll be having this. Now as you can see, we already know that this particular one here is going along the x axis. So that means let's come here. I'm doing the first here. So that means let's write it one by one for the third one. Fx, fy, and then our fz. Now don't forget this particular one is going along the positive x axis. Same thing with this, along the positive x axis. So that means we'll be having, if you do the resolution, this will be your opposite, this will be your adjacent. So that means we'll be having 80 cos of 20 degree. Now as you can see, since we already know for our x is 80 cos of 20, but this particular one here is not going in either of the two directions. In either of the three directions, it's not going along the x, it's not going along the y, it's not going along the z. That means this particular one looks more like the resultant for this. So that means we have to balance this the particular force here. We have to balance it. So that means for us to balance this particular force, the line of action of this particular force we also stretch to reach this particular point, because the line of action of this force always acts along the force. So that means in this case we'll be having y for this, and then we'll be having our z for this. Don't forget that if we do the resolution of this, this will be initially, that will be 80 sine of 20 degree. So that means the resultant here is 80 sine of 20 degree. So that means for our y-axis we'll be having is equals to 80 sine of 20 degree times the angle here, which is, this is opposite, this is adjacent, cos 20 degree. Don't forget the initial force here will be acting, so the initial force here will be acting in this direction. So that means this, as this is the resultant, for our y will be in this direction also, and then for our z will be in this direction also, which is positive y. Positive y, according to the direction of this is positive z. So the upper, going upward will be what? Negative z. So that means in this case here we'll be having minus 80 sine of 20 as the resultant, but sine, sorry, this is sine of 30 because the angle here is 30 degree, sine of 30 degree. So now let's compute this particular force. We'll be having our F to be equals to then 80 cos 20 degree, 80 cos 20 degree, which is equals to 75.17. Okay, let's say 178, 75.1, sorry, 18 in I direction, plus then 80 sine of 20 degree, cos of 30 degree, answer multiplied by cos of 30 degree. So that means we'll be having 23.7, okay, let's say 73.696, 23.696 in J direction, minus 80 sine of 20 degree, cos of 30 degree. So that means, sorry, 80 sine of 20 degree times sine of 30 degree. So that means we'll be having this 13.681 in K direction. So since, and we already know our position is, I'm bringing the position back, 0 in I direction, plus 0.156 in J direction, plus 0.09 in K direction. Then our moment about the third force, the third couple rather, will be equals to, then this will be having our I, J, and K. Then we'll be having a 0.156, 0.09. Then for this, bring this 75.18, then 23.696. Then this will be having minus 13.681. So 3 to be equals to I into bracket. Now since we are picking this, that means we are not picking anything in this direction, picking anything in this direction. So that means we'll be having 0.156 times minus 13.681, 4 minus 2.134. Then also that means we'll be having this one. Don't forget I said, because there was a type mistake in this particular direction, I said is in this direction for your position. Don't forget this is the positive, like I said, this will be negative of z. So that means this particular one should be negative of z. Negative is our positive, the upward is our negative. Thank you. So that means we'll be having 23.696 times 0. That will be positive 23.696 times 0.09. So that means we'll be having 2.13, let's say 3. Then this will be minus using your cofactor, plus minus plus. So that means we're having minus j into bracket. Then if you are picking j, that means you are not picking anything in this sense. 0 times this is 0. Then minus times minus, that's positive, is 0.09 times 0.09 times 75.18, which is 6.77 in j direction. Then for your k, plus k into bracket. So that means if you are picking k, you are not picking anything in this sense. 0 times this is 0 minus 75.18 times 0.16, 75.18 times 0.156. So that means we will be having 11.73. So that means for moment about 3 is equals to, if you do the addition of this, 2.134 minus 2.133. So that's like 0.001. So let's say our I is 0. Then this minus 6.77g minus 11.73 okay for M3. Don't forget for our M2 it is 0 in I plus 0 in J minus 25.455 in K. Then for our M1 it is 20 minus 20 in I, then is 0 in J. The resultant of this couple will be the addition of all this. So that means our MR will be, because if you add this, you'll be having minus 20 in I direction, and if you add this, you'll be having minus 6.77 in J direction, and if you add this, so that means you'll be having 25.455 plus 11.73. So that's negative 37.2 in K direction. Don't forget the unit of this is what? Newton meter. Here comes to the end of the solution of this problem. Thank you very much. Make sure you subscribe to my YouTube channel and always turn on the notification button.